Welcome to the deep dive.
Hello.
Today we're plunging into a stack of sources centered on Mars. We're going to be unpacking the story behind this, well, really remarkable new image captured by a veteran spacecraft.
Right. And our goal is to go beyond just, looking at a cool photo. We want to understand what this specific view tells us, not just about a huge Martian volcano, but also about the red planet's atmosphere, its dynamic atmosphere, and the long-running effort to understand it all.
Absolutely. Think of this as getting sort of an astronaut's perspective on Mars brought right to you here. The sources we have cover NASA's Mars Odyssey orbiter incredible mission, also the giant volcano Arsia Mons, which is featured in the image, and the picture itself, of course, plus insights from the scientists involved.
Okay, let's dive in then.
Let's do it.
So, starting with the visual itself, the descriptions sound pretty compelling. What are we actually seeing in this breathtaking new view?
Okay, so it's a panorama, like a wide shot, taken by NASA's Mars Odyssey orbiter. What really makes it striking is it captures Arsia Mons, one of Mars' tallest volcanoes, kind of dramatically silhouetted against the pre-dawn sky. And it's rising up through morning ice clouds.
Ice clouds, okay.
Yeah, the sources really highlight this as like a rare astronaut-like glimpse of the Martian horizon. They actually compare it to seeing Earth from the ISS.
That comparison really brings it home. And the mention of ice clouds is, well, it's particularly interesting. We often hear about Martian clouds being mostly carbon dioxide, right? Especially high up or, in certain conditions.
Yeah, exactly.
So seeing prominent water ice clouds at dawn like this, it really underscores the complexity, I think. Mars's atmosphere isn't just a simple CO2 story.
No, it definitely adds another layer. And the peak itself, Arsia Mons, the star of the view. Where does it fit in the landscape?
Arsia Mons. It's one of the red planet's most imposing features. It's part of the famous Tharsis Montes. It's a cluster of 3 huge volcanoes near the equator. And Arsia Mons is the southernmost one of that trio.
And immense really feels like an understatement based on the scale they give. It stands, get this, 12 miles high. That's about 20 kilometers.
Wow.
To put that in perspective, it's roughly twice the height of Earth's largest volcano, Mauna, measured from the seafloor.
Twice Mauna.
Yeah, Mauna is about 6 miles, 9 kilometers from its base. Mars just builds things bigger.
It really seems to. And this image is even more impressive when you think about the spacecraft that took it.
That's right. This came from the Mars Odyssey mission, a real workhorse, launched way back in 2001.
2001. And it actually holds the record, doesn't it? Longest running spacecraft orbiting another planet.
It does. It's just incredible longevity, a testament to the engineering and the team at NASA JPL managing it.
And its key instrument for this kind of thing is THEMIS, the Thermal Emission Imaging System.
Yep, THEMIS. Designed and run by Arizona State University, ASU. And it's versatile. It can see invisible light like we see, but also infrared.
Right. Heat signatures. Odyssey's done some amazing science over the years.
Oh, absolutely. The sources mention it's, groundbreaking work mapping subsurface water ice.
Which is vital. Absolutely vital for any future human missions. You need to know where the water is.
Exactly. And it's even imaged Mars's tiny moons, Phobos and Deimos, to figure out what their surfaces are made of.
So, a really productive mission. But capturing this specific horizon view, this, angled perspective, that was a deliberate change, wasn't it? A new focus.
It was. The sources explain that starting in 2023, the Odyssey team began specifically tasking the spacecraft to get these high-altitude shots of the horizon. It really marks a strategic shift, using Odyssey's long life to focus more on atmospheric science.
That shift is really interesting. How do they actually do it? How does Odyssey get these horizon views? Its camera usually points down, right?
Yeah, it usually scans the surface. But it's surprisingly straightforward, really clever. They just rotate the camera, THEMIS, so instead of pointing down, it points sideways to the edge of the planet.
Ah, okay.
So literally just changing the angle.
Right.
And that unlocks a whole new data set. Why is that sideways view so valuable for studying the atmosphere?
Because, well, think about it. Before this, our view was mostly top-down from orbit or bottom-up from landers.
Right, looking straight down or straight up.
This gives us that crucial sideways slice. It reveals the layers, dust, those water ice clouds high above the ground, and a way we just couldn't really see properly before. Capturing the limb, the edge, opens this new window into the upper atmosphere.
I see. So this recent image of Arsia Mons, captured May 2nd. It's a direct result of applying this new technique.
Exactly. And Jonathan Hill from ASU, he's quoted saying they specifically picked Arsia Mons hoping we would see the summit poke above the early morning clouds.
And it didn't disappoint. Love that. You can feel the anticipation.
Definitely.
So, okay, we have the image, we understand the new technique. What key atmospheric insights are we getting from this? And, why does it matter? Well, this angled view lets scientists study the altitude, the density of those layers, dust layers, water ice clouds that we see here. And by comparing images taken across the Martian year, researchers can track how these cloud layers change, how they evolve with the seasons.
Right, so building up like a seasonal weather profile, but for the upper atmosphere layers. There's a quote from Michael Smith at NASA Goddard, a planetary scientist.
Oh, yeah.
He says, "We're seeing some really significant seasonal differences in these horizon images. It's giving us new clues to how Mars' atmosphere evolves over time."
That's fascinating. So it's really providing dynamic information.
Yeah. And Arsia Mons itself, it's not just a passive backdrop in this, is it? It actually plays a role in forming these clouds.
It absolutely does. The sources point out it's the cloudiest of the 3 Tharsis volcanoes.
Why is that?
It's basic physics, really. As air blows up the massive slopes of the volcano, it expands and cools down rapidly, and that cooling makes water vapor condense into ice crystals. Boom, clouds.
Orographic lift, like mountains on Earth causing rain or clouds.
Exactly. The mountain basically creates its own weather.
And this ties into the bigger seasonal picture on Mars.
Directly. The clouds around Arsia Mons get especially thick when Mars is farthest from the sun. That period's called aphelion.
Oh?
And that's also when this huge band of clouds, the aphelion cloud belt, forms right across the planet's equator.
So this image with the summit poking through those thick clouds, it's showing the volcano interacting directly with that massive seasonal cloud belt.
Precisely. It's a fantastic visual confirmation.
And this isn't just, interesting science for its own sake. The sources are pretty clear on the practical relevance.
Absolutely. Understanding Mars's clouds, the dust layers, the overall weather patterns, it's crucial, especially for planning future missions.
Particularly for the landing phase, right?
Yeah.
Entry, descent, and landing EDL.
Exactly. EDL is incredibly complex, very risky. You absolutely need to know what kind of atmosphere your spacecraft is going to be hitting at high speed.
Yeah, you need accurate atmospheric models. This kind of data feeds directly into that. It's fundamental for getting down safely.
Definitely fundamental. So let's try and sum up what we've unpacked from the sources today. What are the key takeaways?
Well, first, I think, is how a single, really spectacular image from a spacecraft that's been up there for, over 2 decades now?
Yeah, more than 20 years.
How it can just fundamentally shift our perspective, giving us this astronaut's view of the Martian horizon we didn't really have before.
Right. And this specific view highlights Arsia Mons, this giant volcano, showing how these huge features actively shape local weather, especially with those striking cloud formations tied directly to seasons and Mars's orbit around the sun.
And maybe the most important point, strategically speaking, this new way of looking, pointing Odyssey's camera sideways. It isn't just for pretty pictures. It's a calculated move for a long-running mission. It's providing critical data on atmospheric dynamics, cloud evolution.
Yeah, information that directly feeds into planning. Planning for future human exploration, helping us figure out how to land safely on Mars.
It's really quite remarkable when you think about it. This image volcano summit, clouds, comes from a spacecraft launched before a lot of people listening were even born.
That's true.
And it's still teaching us fundamental things about how dynamic Mars actually is.
It really is. It makes you pause, doesn't it? Given that just changing the angle, tweaking how you use a long-standing tool like Odyssey's camera can unlock so much new science and actually help future missions. It makes you wonder what other tools or perspectives, maybe things we've had for ages, might be holding crucial insights about our universe.
Yeah.
Insights just waiting there if only we decided to look at them a little differently.